Oh geez, I'm glad you guys are here. Somebody was telling me that there's a new way to write numbers around here, and that kind of scares me. Oh jeez! So when you're talking about exponential notation, or exponents, you're talking about a system of writing numbers that makes it really easy to take these big numbers and make them something smaller looking so that you can understand them a little quicker. You'll see it a lot in the different sciences and higher level maths that you're going to take, and they look sort of something like this. So you have your base, which is a really big number right there, and then you have your exponent, which is the small number up top. So base, exponent. And all this says is, and contrary to popular belief, it's not 3 times 8, or 8 times 3. It's 8 times itself 3 times. So you got 8 times 8, which is 64, and then 64 times 8, which would be 512. So that's what we're working with here. Let's go to a couple examples and I'll show you what we're talking about. The first example I want to look at is 2 cubed. Now, when we're breaking down exponents, we're going to multiply the base by itself however many times the exponent says. Another way to write this would be 2 times 2 times 2, and then we get 2 times 2, which would be 4, times 2, which would equal 8. So 2 cubed, or 2 to the third power, would be equal to 8. But I'm sure you guys know that already. This is a review, so I'm not going to dwell too much on how to do exponents or how to solve exponents, as much as I am going to focus on the properties. The first property I'm going to talk about is when you multiply 2 same base exponents, or exponential terms. The first thing that jumps out at you when you see this is we have 2 terms that have the same base. So we have 4 to the 4th power times 4 squared, or 4 to the 2nd power. They have the same base. Therefore, we can do something kind of cool. We can combine their exponents and make this all one term. So we keep same base, and then we multiply, or we add together the exponents. Now, you might be asking yourself, well, what if I had something like 5 to the 3rd times 6 to the 3rd? Can I combine the exponents there? No, because it's not the same base. So it doesn't quite work. It doesn't work at all, actually. But we can combine the exponents of like base terms to get a singular term that we can work out. There's a couple different ways we can go about this. If we're going to write this out, we get 4 times 4 times 4 times 4 times 4 times 4, which is great. And this is another way that I like to do it when I work it out. When I work it out by hand, is I like to pair things off as much as possible. So we get 4 times 4, which would be 16 times 16 times 16. Combine these down. 16 times 16 is 256 times 16. And 256 times 16 gets us 4,096. So let's recap what we just did. We had 2 terms that had the same base, different exponents, and we combined them to one term with one exponent. And then we broke it down and multiplied. Alternatively, and probably ideally, you'll just put it in your calculator, but this is another way you can do it. We broke it down, we paired it off, we multiplied it out, and we got a final answer of 4,096. So next thing I want to do is give you guys one to work on. The one I'm going to give you is 5 squared times 5 cubed. Go ahead, pause the video, take a second, work this out. So when I'm doing this, I'm looking and I'm checking, and I'm saying, I'm looking and I'm checking and I'm seeing, oh, is this the same base? Well, 5 and 5, those are the same. That's the same number, so it's got to be the same base. So I can rewrite this a little differently. Notice, kept the same base. All I did, add the exponents together. When I do that, I'm not going to break it down again, but you could break it down into 5 times 5 times 5 times 5 times 5. Or just put it in your calculator, and when you put it in your calculator, you get 3,125. You might be asking yourself, Mr. T, if there's a way to simplify when we're multiplying terms, well, shouldn't there be a way to simplify when we divide? And you're right. When we have two like base exponential terms, we keep the same base and simply subtract the exponents. So we subtract 2 from 4 and get 2. So this term here breaks down or simplifies down into 4 squared, or 4 to the second power, which is of course 4 times 4, which would be 16. So let's take it back. We had 4 to the 4th power divided by 4 squared, and we simplified it down to just 4 squared, which we know is 4 times 4, which is 16. And that's true for, you can do this process for any like base division problem you have. So why don't we try one, or why don't you try one on your own? I'm going to give you 17 to the 6th power divided by 17 to the 5th power. Go ahead, pause the video, take a shot at it, and come back in a second. Okay, so when I look at this, I see two like base exponents, two like base exponential terms, which means when I simplify this, I keep the same base. I keep that 17, and I just subtract the exponents from top to bottom. So 6 minus 5 would be 1. And 17 to the 1st power is still 17. Anything to the 1st power is just itself. But in this case specifically, it's 17 to the 1st power is equal to 17. There's a couple more things that I want to talk about. One of them we saw a little earlier, or in the last example, which would be what happens when you get a number to the power of 1? Well, a number to the power of 1 is simply just itself. It's the base. You're not multiplying it by anything. You're only taking, in this case, 16 one time. And 16 one time is 16. Now let's look at the next one down, which is 12 to the 0 power equals 1. Anything to the 0 power is going to be 1. The reason behind that, in really big terms, is that it creates the multiplicative identity, which, think about it, what number can you multiply by anything, and what number can you multiply anything by and get the number you multiplied it by back? 1. So 12 times 1 is 12, 15 times 1 is 15, 107 times 1 is 107. That's what I mean by multiplicative identity. So that's why anything that is to the 0 power is 1, as it's creating that multiplicative identity. Well, that's all we're going to cover today. So make sure you come back tomorrow so we can talk about negative exponents and exponents of exponents and all sorts of other exciting things. Maybe you just want to see me, or maybe you're only concerned about your grade. I wouldn't blame you on that one. See you guys tomorrow.